All right, so for number 23, it says at 800 Kelvin, the equilibrium constant for the following reaction is Kc is 3.1 times 10 to the negative fifth, and it's I2 at equilibrium with 2I. They're both gases. And then it says if an equilibrium mixture in a 10-liter vessel, okay, so it's going to be in 10 liters, contains 2.69 times 10 to the negative second grams of I. How many grams of I2 are in the mixture? Okay, so like I had said, this is similar to, I think it was example 14 that we did. And there's a video on example 14 if you need to look back at that at all. So when we look at this, they give us the Kc expression. So if you're like, I'm not really sure where to start, it says if an equilibrium mixture in a 10-liter vessel contains this much. So you're at equilibrium. There's no need for an ice table, no need for anything like that. We're at equilibrium, so I'm going to use Kc. Right? The Kc expression, just write the expression first, is I squared over I2. Now I did Kc because they gave me Kc. Now brackets mean molarity. I have grams and liters. So before I can plug into the Kc expression, I need molarity. So what I need to actually do is take 2.69 times 10 to the negative second grams of I. I need to go to moles. So 126.9 is the molar mass of iodine. It's just I. That's what they gave me here. This is just I. So start by finding moles. 2.69 E negative 2 divided by 126.9. 2.12 times 10 to the negative fourth moles of I. That's moles. Now I'm going to keep it in my calculator, but you at least need to go out to 3 sig figs, if not more. Right? At least 3. I would recommend 4, maybe 5, because I had somebody this morning try to round to 2 and mastering told them they were wrong. So here's moles, but again, I need molarity. I need moles per liter. So 2.12 times 10 to the negative fourth moles over 10 liters. 2.12 times 10 to the negative fifth molar. That's I. That's your concentration of I at equilibrium, because this mass of I was at equilibrium. So here's what I can plug into K. So here's what we can use. Here's Kc. Right? I have 3.1 times 10 to the negative fifth is 2.12 times 10 to the negative fifth squared. And we have to solve for the concentration of iodine. So don't forget to square this. And you're solving for I2. So really what you're doing is you're multiplying I2 over dividing 3.1. So I'm going to do 2.12 e to the negative 5 squared divided by 3.1 e negative 5. Okay, so I need to erase a little bit. So I have some space. So again, here's what I did in my calculator. I multiplied I2 over and I divided. So I did I2 is 2.12 times 10 to the negative fifth squared divided by 3.1 times 10 to the negative fifth. And for the concentration of I2, I got 1.45 times 10 to the negative fifth molar. Now there's my concentration. But if you read the question on mastering, it says how many grams. So now we have to go back out to grams of I2. So remember that molarity is moles over liters. Here's our molarity. 1.45 times 10 to the negative fifth. X moles over 10-liter container. Right? The size of the container doesn't change. 1.45 times 10 to the negative fourth moles of I2. And then just go to grams of I2 using the molar mass. So 126.9 times 2. That will get you your grams. So essentially, this is a problem where you had to take grams, use the idea that you need molarity in here, solve for molarity, use K to solve at equilibrium, and then go back out. So that's 2023.